And that is, in fact, what we find. When we take a look at this graph here, we can see that on the y-axis is a value representing the ratio between carbon-13 and carbon-12, recorded at the same site, actually in Mauna Loa, Hawaii, as the carbon dioxide data we looked at earlier. And we can see as we go from 1980 towards 2008, there's a general downward trend in this ratio of carbon-13 to carbon-12, consistent with the idea that the source of additional carbon dioxide in the atmosphere is from a high carbon-12 ratio source, and the most likely explanation for that is the most likely source of that is fossil fuels, which we are burning in high abundance and ever increasing abundance. When you take a look at this, there is in this record, and you might have noticed in the other Mauna Loa record, an oscillation in this, which is superimposed on top of this trend. We'll talk a little more about that later on in the why that should be there a little later on in the unit. So this decrease in the ratio of carbon-13 to carbon-12 is additional evidence in support of the theory that human produced carbon dioxide produced by the burning of fossil fuels is what is contributing to the increase in temperatures and other and resulting effects that we've seen globally over the past 60 years or so. And so this supported hypothesis, a hypothesis which has additional evidence which has been sought and collected in support, and which has observational evidence to support it, is known as a theory. So a theory is an explanation that successfully accounts for the data that we've collected so far. It makes it all make sense. So at this point, there's certainly other evidence out there. And also some would argue that there's evidence that is out there against this claim. So what I'd like you to do is to take a few minutes, and I'll post a couple of websites online that you can use as a starting point to find an additional piece of evidence, either in support of or that weakens this claim in your mind that that climate change we're observing is anthropogenic. It's coming from this increase in carbon dioxide that humans are producing. And I'd like you to, when you find that, to just briefly describe it and provide a URL and your source on the unit in an anthropogenic climate change form that I'll put on the Unit 1 topic page. So just take a few minutes to do that after you finish watching this. Couple slides to go. So there is evidence for this theory of anthropogenic climate change, and clearly there is among some, although the scientific community is largely more than 90% of climate scientists, I think even higher than that, are subscribed to this particular theory, this particular explanation of the changes we're seeing in climate. But it is up to individuals to evaluate the evidence, and when you evaluate the evidence and make your decision one way or the other, accepting a theory can have consequences and can dictate your responses. And as we know, our current president apparently looks at this data with does not believe that this is the case, and so we saw this earlier in the spring.
My solemn duty to protect America and its citizens. The United States will withdraw from the Paris Climate Accord.
So this was a major news story after the United States was involved in helping to negotiate global responses to this rising these changes in climate, based on the theory of anthropogenic climate change. And so this was a major news story when this decision was made. That is the federal response currently under this administration. But as we've seen actually in yesterday's New York Times, in fact, there was this story about states actually picking up and state governments continuing to subscribe to this theory and believing there's something that we can and should be doing about it, including Massachusetts, New York, and others, and agreeing to increase and try to meet those Paris climate negotiated targets, and to actually increase their their plans to try and do something about carbon emissions going forward. We'll hear a lot more about this as the year goes on. And our Smith Scholar Series this year is a series of scientists and policymakers who are going to be discussing climate change, and it should be a really exciting conversation to be a part of going forward. For us right now, and that's the reason I chose this particular, maybe not directly, but certainly this climate will have an impact on biology. It's not directly biology per se, but it does provide us with a great example of how science proceeds and gives us an opportunity to review key scientific terms that we're going to be using over and over. And just to review those terms, which have been highlighted and read throughout this talk, we're talking about observations, which generally are the use of the five senses or a measuring device to characterize natural phenomena, and that's just the facts. So when you report an observation, you describe what you see or smell or measure, and then your job, once you have observations, that's the first part of science, is to make observations. Some scientists are just observational scientists, but generally once you've made observations, which is what science is built around, the natural human tendency is to want to explain those observations. And so the efforts to explain lead us to hypotheses, which are possible explanations for a set of observations. And these hypotheses, if they're going to be scientific and valid, need to be testable in some way. They should make predictions. People often think of hypotheses as an educated guess or as a prediction, and I want to get you away from that notion. A hypothesis is a possible explanation for what we see. It's not a guess. It's based on data and our best understanding of how things work and what might make sense given what we know. And it must be testable. It's then the scientist's job to actually test those hypotheses, to try and collect that data, and to see if the predictions made by the hypothesis, or that the hypothesis leads to, bear out. If you collect observations in support of a particular explanation or contention, that those observations are referred to as evidence for your contention or your explanation that you're advancing. So it's observations applied or evidence. If we gather enough evidence to support a hypothesis that seems to bear out and match up, oftentimes we'll convert our notion of hypothesis. We'll use the term theory to explain an explanation that's backed up by significant and convincing evidence, often used synonymously with hypothesis. People will toss these around back and forth, which can get a little confusing. When it's capitalized, a theory, something like atomic theory or gravitational theory, some would actually capitalize this theory in anthropogenic climate change theory. The notion is that it explains all of the observations that have been made to date. So it matches up. The thing about theories is you can't make all the observations. So any theory, it's impossible to 100% prove any theory. But they are the best explanations that we have. And if we find observations that don't fit with that theory, we have to revise our theory or find a new one, a new way of explaining things. And science is full of examples of theories that have been revised and changed or even thrown out based on new observations that get made. And so finally, to provide our overall definition of science, we can define science as our understanding of the natural world based on systematic and repeatable observations. That's key. Your observations must be systematic, repeatable, and technically should be able to be made by anybody. Everybody should agree we're seeing the same thing. And the theoretical explanations that are supported by observational evidence. So these are the terms we're going to be using. These are the things that sort of throw contentions and ideas about the world around us into the pile of science, and that's what we'll be building our course around this year. So I'll look forward to seeing you guys tomorrow, and we'll talk a little bit more about climate change, take questions on that, and hear a little bit about the evidence that you guys uncovered. So we'll see you then.